Okay, this video is really a follow-up to the video on quadratics, and this is looking a little bit closer at those situations where a is not equal to 1. So just to remind ourselves, this is the general form of a quadratic equation, and this left-hand side is what we're interested in factorizing. So we've got an x squared term, an x term, and then we've got our constant and then the coefficients of x and of x squared. So when we say a is not equal to 1, we mean this coefficient of x squared. Okay, so just to kind of recap on the example in the previous video, if we want to factorize this expression here, well, I've done it sort of backwards way round, really. So if what we're trying to achieve is this this expression, so we're breaking that 5x into 4x plus 1. Okay, so having split that, and the reason I put these underlines and overlines in is just to sort of illustrate that's what we've done first. But now we're going to look at each of these underlined portions separately and factorize them. So that means in the first case of these two, we can take 2x out of that. And out of the second one, well, we're sort of just factorizing 1 out, aren't we? Into x plus 2. So we've got 2x into x plus 2 plus 1 into x plus 2. And we can write that as 2x plus 1 into x plus 2, because obviously that 2x multiplies these two and this 1 multiplies these two. So that's what we're left with. Now this method is goes by a number of different names. Exploding the middle is one. Breaking x I like because it sounds a bit like breaking eggs, but anyway, that's what we do. So let's just have a look at an example from the beginning, if you like. So here we're just factorizing 2x squared plus 11x plus 12. Right, so what we're going to notice here is if we multiply the 2 by the 12, we're going to get 24. Now, if we look at how that can factorize, it could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. We finish then because we're just going to get all the reverses, aren't we? 6 times 4 and 8 times 3 and so on. And we don't really need to do that. Now this is a kind of slightly more straightforward one because we've just got pluses involved in here. This 2 pluses here, so we know everything's going to be positive. But yeah, so if we look at 11 and look how we might construct 11 from these factors, then 3 and 8 works nicely, and that gives us 11. So we're going to break our 11x into 3x and 8x. I've put the sort of this kind of minus thing in here because in general it's going to be plus or minus depending on the signs here. But as I say, this one is just pluses, so we are just taking the positive part. So I'll come back to that in a minute. All right, okay, so like before, now we've got that, and we notice incidentally that 3 times 8 is equal to 2 times 12. So that's interesting. Well, just arises from this, of course. So if we factorize each in turn, then we're going to take x out of the first two and 4 out of the second two, giving us this expression, which we can therefore write as x plus 4 into 2x plus 3. And if this was an equation with that would just give us our solutions directly. Now, what you might say is, well, you put 3x plus 8x, but what happened if you just happened to write it the other way around? Would that blow the whole thing? Well, no, and here's an illustration why. If we wrote it like 2x squared plus 8x plus 3x plus 12, then in this case we would just factorize 2x out, and there's 2x into x plus 4, 3 out of there, 2x plus 4, and we'd get 2x plus 3 into x plus 4 as same as that. So So that's kind of how it works for that. Now let's look at a slightly more complicated problem. This is actually written as solving a quadratic equation. Now it's slightly more complicated because first of all it's got negatives in. Make it too hard, but that's just one slight difference. And the other one we've got that this is not a prime number. So we'll be looking at 2. 2 is a prime number, and we same with 3. We'd know that it would be 3x into something times x into something, and so on. But when it's not a prime number, then in this case, for instance, we don't know whether our final factorization is going to be 4x plus something into x plus something, or 2x plus something into 2x plus something. Now, at this point where we don't have a prime number, this method is really starts to really come into its own. But yeah, fear not. At the end of the day, you've still got other methods available to you if you've got something that looks fairly complicated. I mean, we don't know that we can factorize this at all, do we? Actually, just by looking at it. Or if you can't tell, then you know you're obviously going to be very experienced at looking at them. So all right, so we don't know though. So what are we doing? Right, okay. So if we take our 4 and our -5 gives us -20, and we look at the things that multiply together, will give us -20. Then we've got these possibilities here. We then can sort of switch the signs around, can't we? You might want to do that. It gives you twice as many sort of things to look at. But usually, you know, you can just forget about the signs and then work out. Once you've chosen the pair, then choose the signs. And in this case, I think it's probably pretty clear that, you know, a 20 and a 1 gives us the possibility of getting our -19, obviously -20 and +1. So that's what we've done. We've exploded the middle, broken the x or whatever in there, -20 plus x. I put 1x because it just kind of helps a little bit, -5, and therefore we could factorize 4x out of the first 2 terms and just 1 out of the second 2, giving us 4x plus 1 into x minus 5 equals 0. And since this says solve the equation, then we could see from there that the solutions to that equation are -1/4 and 5. Okay, so that sort of covers it really. Just one other thing that is worth noting is actually this also works if a is equal to 1. So it's a general method for solving, and so you might want to just apply it to those situations as well, just to give you a bit of practice, perhaps, and to maybe end up with a consistent method of factorizing. So so that's basically it. So hopefully that helps. I think it's a very kind of neat little method. So yeah, thanks for listening.